Hello everyone. Today we would like to discuss about scattering of light. So this is another natural phenomenon, scattering of light. First of all, what is scattering? Scattering is a phenomenon just like reflection, refraction, dispersion. Like that, it's one of the phenomena that occurs when sunlight is deflected in all directions. So when sunlight is passing through atmosphere, so that sunlight is deflecting. Deflecting means changing its direction. So here if you can observe, so this is a cloud droplet, maybe water droplet if you consider. So this is, let me take as a water droplet. So when sunlight is striking on this water droplet, something is happening between this water droplet with the sunlight. Now from the sunlight, here you can see the light is scattering in all directions. So this phenomena only we known as scattering of light. So to make you understand this first, let me make you understand one effect which we already know that. So that is nothing but Tyndall effect. So here I am going to show the virtual demonstration regarding the Tyndall effect. Tyndall effect. So here we have taken a, a clear water. It's clear water, and if you can see, the water is a light is passing through water. Yeah, at here the light is passing. So the image of light. So this is the light image. So it's something like that, white in color. Suppose in that water, if we add a few drops of milk, now right now, so milk is adding. So now at here milk is added. Now if we add milk in the water, now the water solution changes due to because of the fat and the protein particles in the milk. Now the water became a kind of solution. This solution we called as colloidal solution. I hope you know what is the meaning of colloidal solution. The size of the particles are little bigger. Now here we can observe the light which is at here. Now this light which is coming through this mixture, so it is something like different in color. Now it is not white color, so it is turned to orange or one shade of red. Now here you observe, after adding milk, what is happened? So here two things you observe. So the entire color of the solution here has changed. So if we can observe that close up, so the mixture of the water right at here, so that is turned, so it is something is turned to one of the pale blue. It is turned to a blue in color. So why? Because the milk contains heavy size, little bigger size of the protein particles and the fat particles, and they all are equally distributed through the water. So here we can observe, so here the water is not transparent, but the light is coming from the bottom. Here you observe the light is coming all the way like that. So this is the light source, the bottom at here. Now the light is coming through the water which is focused on the screen. Now that light now becomes to as an orange or different color. Suppose if we add more milk, so here I added extra few drops of milk. So it means the concentration is increased. Now it is totally dissolved. Now we can observe again change in color. So now the color will be turned to little darker. Now the reflected light which is on the screen, its color gets changed. Now here you can observe the color became dark. Now this is, I can take a light red color. Now here the question, how these colors are coming on the screen like this? If we add something, if we add milk in the water, how the colors are changing? If we add milk in the water, how the colors are changing? Yeah, this is the phenomena of scattering. So what is that? Let us see at here. From the early concept of dispersion, we understood that the prism disperses white light into 7 consistent colors. So from that concept we understood that white light consists 7 colors. White light consists colors. So these colors we are representing in terms of wavelength. So if you can pick up any color, so that color supposed to be represented in terms of wavelength. If you remember what is wavelength, suppose we were treating light as a wave, so the distance between two successive crests or trough is known as wavelength. So from here to here, so this we take as wavelength. Now these all colors are having different wavelength, all shades. When it comes to scattering, suppose if any object is appearing that particular color, suppose if you are seeing on the screen yellow color, so this yellow color is coming from the screen. So it means that this screen is reflecting only yellow color and it is absorbing all colors in the light. So this is something is different. Suppose you are looking a green leaf. Take a green leaf which is appears to green color. So if the leaf is green color, so we will say that the leaf is absorbing all colors which are present in the light, but it is only emitting, giving back. It is only emitting green color. So that's why it appears green color. Suppose this shirt appears black color. Why it is appears black color? There is no black shade in the white light. So it means that this shirt is absorbing all colors which are present in the white light. So it is not reflecting any color, or we can say another word, it is not reflecting any light. So that's why this object appears black color. Suppose if you take an object is appearing white color. Suppose you take this paper, so this paper is appearing white color. So this paper appears white color. So if this paper appears white color, what do you think? So all wavelengths which are present in the light, it is reflecting back. it is not absorbing any light or any color which are present in the light. So this is something is interesting. So colors corresponding to wavelength. So here we will observe how this scattering can be understand much more. So here I would like to represent all colors which are present in the light. So this we termed as visible spectrum. So each colors we represent as a wavelength. So lambda is nothing but wavelength. Suppose you pick up this violet color, so it's having wavelength of 400 nanometer. So nanometer means I can say that 400 times 10 power minus 9 meter. So 10 power 9 we are calling as nano. That's known as nano. Or if we can do simplification, we have to divide 400 upon 10 power 9. I hope you know how to write 10 power 9. So we don't want those mathematics at here, but I would like to show the wavelengths of the colors. Here all the wavelengths of color. So here we need to understand more at here. So this is important. The red color wavelength is greater than the blue and violet color. Red color, wavelength of red color is greater than wavelength of blue, or if you can take that wavelength of violet color. Wavelength of violet color. So if you consider, so light consists with GR. VIBGYOR. So this is the shortcut we used to understand about colors in light. So the red is loss, it is having greater wavelength, and the violet it is starting, so it is having less wavelength. So this is at here. So this is the something about wavelength. So here I would like to make you, so this term is important. The red wavelength is greater than the blue or the violet. So because we need that point ahead. Suppose, let us come to main concept in the scattering. So the scattering of light in the atmosphere, it depends upon the size of the scattering particle. So as we saw in the Tyndall effect, if the milk particles are added in the water, so the milk particles contains proteins and fat, automatically their size are bigger. So that's the reason light is scattering due to the fat molecules or milk protein molecules in all directions. So that's the reason the light has changed, the reflected light has changed. So here the interaction of the scattering particles. Where these scattering particles are present? They are present in the atmosphere with the light. So the size of the scattering particles which are present in the atmosphere interacting with the wavelength of light, correct word? So it's a wavelength of light. So that gives something like different optical phenomena. So let us see the first. Suppose if the size of the particle is very smaller. So let you take at here size of the particle approximately equal to 0.01 to 1 micrometer. So micro means 1 times 10 power minus 6. Very small. So those particles are known as aerosol particles. The particle size, I think, first this is let we discuss. So if the size of the particles, let's take a raindrop size, the size of raindrop equal to 10 to 100 micrometer. Micro means 10 power minus 6. So this we call as micro. So that much small. If the light is interacting this very small particle of size of the raindrop, so because of that we will see effect that the white clouds are white. What could be the reason? Because the scattering of light with the raindrops. So the raindrops are bigger in size and they will scatter all wavelengths of light in all directions. So that's what we saw in the first slide. Yeah, this is it here. Now here we can see the white light is scattering in all directions. Why? Because the size of the raindrops at here, so it is interacting with light. Now this size is bigger than the wavelength of the light. So that's the reason all wavelengths are scattering. If all wavelengths are scattering, again we will see the white color. So the clouds are appears white due to the scattering of light. Suppose if we take the particles which are the smaller than that, sometimes we see the blue sky or the blue moons and the blue sun. So the blue in color, the sky appears blue in color. So that is due to because of the scattering. So the scattering particles of size, this is very small, 1 micrometer. Micro means 10 power minus 6 meter, 0.01. See, here you can see. So this is the size of the particle with the compared to the wavelength of light. Now in this case, the wavelength of light is scattered depends upon the size. So we can see only that particular colors. Now let me take one other last. If the air molecules are much smaller than the previous raindrop or any other what we consider in the atmosphere. Now this is the size of the particle in the atmosphere. So this much small size, 0.001 millimeter. Milli means 10 power minus 3 meter. So this much small particle is interacting with the light of different wavelengths. So in this case, the light is also having different sizes of wavelength. So here the blue wavelength, which is comparatively equal to the size of the air molecules, so that scatters. That's the reason at here the sky appears in blue color. Or sometimes, so this is the same reason we can able to understand about why the sunset and sunrises are not appears in blue, so they change in the red or orange colors. So this is all final, I can say that. So different sizes of the particles interacting with the different wavelengths of light. Different sizes of the particles interacting with different wavelength of light. So that causes for different phenomena like white clouds and white sky, sometimes blue moon and the blue sun, or blue sky or red sunsets. So in our concept we are having before that, so here I'm having a table. So this table you can remember. So this says about the air molecules and the corresponding size. So this is the corresponding size, how small it is, and the corresponding phenomena. If the size of the air molecules are very small, so that is scattering of visible light. So the phenomena which is happens at here, blue sky, red sunset. So this is what we need to talk much clearly. So white clouds, what could be the reason for white clouds? So here the reason for white clouds is the size of the particles in the cloud. So their size is little bigger than the wavelength of light which are present. So that's the reason all wavelengths which are present in the white light, they will scatter in all directions. So the white light, it scatters all directions. So that's the reason the clouds appears white. So the clouds appears white or gray. So here the process is scattering by raindrops. So here visible light of all wavelength is scattered in all directions. So clouds are optically thick with respect to light scattered, but they do not absorb light because all light gets scattered. So due to this, by the appearance of cloud, one can judge whether it will rain and how strong the storm will be. Sometimes we can observe the clouds are dark. So why they are dark? Now you can guess the answer. Why they are dark? So this is something is important concept to me. Blue sky. On clear days, the sky is blue, and on hazy days, the sky is white. Here, what is the process? Here, the process is scattering by air molecules. So, the air molecule size is comparatively very small, and that small air molecules are able to scatter blue light. So the blue light wavelength is smaller than the size of the air molecule. So that's the reason the shorter wavelength, blue or violet, are scattered more efficiently by the air molecule than the longer wavelengths like red color. So here the size of the particles are the very important in the process of scattering. So by the conclusion, I can say it here, the sky, clear sky, distant objects have bluish color. So when sometimes you can observe the sunset and the sunrise times, the color of sun is different. During the early morning time, so it's a beautiful orange sun, that is the sunrise, and during the noon time, so it's the blue sky and the white sun, and during the sunset again very nice orange sun. So during the same day we can see the sun in different colors. So early morning, so the sun appears orange, and but in the noon time, so again it turns to white, but the sky turns to blue, and again evening sunset, so it's again a dark red color or again orange color. So what's the reason at here? So the color of sun, the color of the sun at sunrise and sunset, the sun is yellow or orange or red. So these colors change due to because of the air molecule along with the very fine, very smooth dust particles. So if the atmosphere contains air molecules along with some dust, the dust particle size is little bigger than the air molecules. So that the size is scattering the wavelength of red color. So on the clear days, only the blue light is scattered away. But on hazy days means like this. The yellow and the orange wavelengths are also scattered, and only the red remains in the direct sunlight. So due to because of that bigger size of the dust particles and the air molecules, so now these are the responsible for the scattering of red light. So that red wavelength which is present in the sun. So that's the reason during the sunset and the sunrise, the sun is appears to either orange or red color. So by conclusion, you can say that red sunsets suggest that there is a dust in the air. So maybe pollution or haze over the ocean or any volcano activity or dust storms, all this. So that is cause for the scattering of red color in the sunlight. So this is all about the scattering phenomena. The scattering is happens due to the interaction of the light with the particles which are the present in the atmosphere. So it depends upon the size of the particle. If the particle size gets changed, the scattering color gets changed. So here the size, corresponding size along with the corresponding the wavelength of light, that gives blue sky or phenomena of form of the white clouds or sunset or sunrise. The sun appears dark red and orange colors. So this is all about scattering of light.